Welcome to this video on the topic of binary numbers. In this video we're going to go over two concepts. The first one being what is a binary number, and then secondly we're going to have a look at how we can convert binary numbers into decimal numbers. Now jumping straight into it, when we're thinking of a binary number, the best place to start is looking at our own number system. So if we were to count upwards from 0 in our own number system, we're going to start from 0, then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And for us this seems really natural because this is the system we've been using pretty much all of our lives. Now this system here, it's actually got a name and we call it the decimal. Decimal meaning 10. Now the reason we can't in this number system is, well, some would argue it's purely because we've got 10 digits on our hands. So it's nice and easy to count. Now with this number system in particular, what you'll notice is that there are 10 different numbers. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 10 unique numbers here. Now conversely, when we're working in computer systems, a computer, it doesn't have hands and it doesn't actually count in the decimal number system. Rather, it counts in a system called the binary number system. And if we were to count upwards from 0 in binary, then we're going to start at 0, same as decimal. Then we were at 1. And here's where things are different. In the binary number system, we only have two unique numbers that we can use to represent all the numbers in the world. So after we hit 1, we have to improvise. We have to go 1, 0. After 1, 0, we go 1, 1. Then we go 1, 0, 0. And we're going to go upwards in this pattern. So counting up, reading this in its decimal form, we go 0, 1, 1, 0, same as 2, 1, 1, same as 3, 1, 0, 0 is equivalent to decimal 4, 1, 0, 1 is the equivalent of 5. So what you're going to notice is that you have to use a lot more digits to express the same numbers that you would otherwise in the decimal number system. So this one over here, this is the binary. Now the reason we're going to look at the binary number system is because this is natively what a computer will deal with. So if you ever want to understand how, say, communication between computers work, how images are stored on computers, or anything related to how a computer works, you have to be able to read and understand the binary number system. Now, what we're going to do is we're going to have a look at how we can interpret binary numbers. So if we go down to these three examples here, we've got three binary numbers. So in example 1, it's 0, 1, 0, 1. Example 2, it's 0, 1, 1, 0, 1, 0, 0, 1. And example 3, it's 1, 1, 0, 0, 0, 1, 0, 0. Now, first thing you're going to notice is between these examples, they're of different sizes. So in example 1 here, we've got, goes from here to here. So there are only 4 digits in this example. Now this sort of number here, we call it a 4-bit wide binary number. And the width of the number itself is going to determine how big the number or how big a number it can represent. So I'll get these examples and move them to the side over here for now. Alright, now if we were going to interpret this number or read it, then what we're going to do is we're going to have a look at firstly the arrangement of the number, and then we're going to have a look at whether the individual numbers, say here, 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 are either 1 or whether they're 0. So what we're going to do is this number over on the far right here, it actually represents a placeholder. And what it's going to represent is a +1. Now the second bit along here, it's going to also represent a placeholder, and it's going to be +2. Third one, going to be +4. and this fourth one is going to be plus 8. Alright, now to convert this into decimal, what I'm going to do is I'm going to go through, and every number that's 1, I'm going to highlight it. So there's a 1 there and a 1 there. Now next step is, whenever I've highlighted a number, I follow down the arrow and I highlight the number that's got a plus on it. So first one, and this third one here. Alright, now to convert, what I'm going to do is I'm going to write 0, 1, 0, 1, that's base 2. I'm going to write it as 1 plus 4. So the numbers that I've highlighted. And then I'm going to evaluate that, and it's going to be 5. And you can put a little 10 there if you want, but you don't have to, it's implied with base 10. So what we're going to find is 0101 is equivalent to the decimal number 5. Now, going over to example 2, we have a similar number, but it's a lot bigger. First thing we're going to notice is this number. It's not 4 bits wide, but rather it is 1, 2, 3, 4, 5, 6, 7, 8 bits. Now, to convert this to a decimal number, we're going to use the same method as before. Firstly, I'm going to write underneath, I'm going to write plus 1. Then next digit along, I'm going to write plus 2. Third digit along, I'm going to write plus 4. Fourth digit along, I'm going to write plus 8. And perhaps what you've started to see is there's a pattern emerging with these plus numbers. So if I've gone plus 1, plus 2, plus 4, plus 8, every time I go up, they're doubling. So if the last digit was plus 8, then the next one's going to be plus 16, plus 32, and then it will be plus 64 and 128. Alright, next step, I'm going to get my highlighter, and I'm going to highlight all of the numbers that are 1. Once I've highlighted them, I'm going to go down, and the numbers that I've highlighted, I'll follow the arrows and I'll go plus 1, plus 8, plus 32, plus 60. Now, time to convert. We have 0, 1, 1, 0, 1, 0, 0, 1, space 2, and it's equivalent to 1 plus 8 plus 32 plus 64. Putting this all in my calculator, this is all going to sum up to be 105 base 10, or decimal. But remember, I don't need that 10 in there. It's implied when we're working in decimal. So that's the first 2 examples of how we can convert binary numbers. Now, example 3. Let's have a go at this one, but let's take a few shortcuts. Let's go, put it there. And rather than drawing all of these arrows, what I'm going to do is, first thing is I'm going to just highlight all the numbers that are on. So I've got this one here, and this one here. Now, underneath all of these numbers, I'm going to write plus 1, plus 2, plus 4, plus 8, plus 16, plus 32, plus 64, and then plus 128. Alright, now I'll just go back and I'll highlight the plus numbers that are underneath the ones, like so. Alright, now to convert this, all I need to do is I'm going to say 4 plus 64 plus 128. Now I just need to put this in my calculator. We get 196 base 10. Alright, let's go for one more example and we'll make it slightly different. We've looked at a 4-bit number, we've looked at an 8-bit number. Let's go for something bigger. Let's go for 0, 1, 1, 0, 1, 0, 1, 0, 0, 1, 0, 0, 0, 1, like so. So this number is quite a bit bigger. Now, I don't actually know what this one's going to be because I just made it up on the spot. But let's have a go. We'll look at the numbers and we have to highlight our ones first. Alright, now we'll go back and we'll go plus 1, plus 2, plus 4, Alright, so we've got all the numbers. Now I'm going to go back and highlight the ones we need. Plus 2, plus 4, plus 16, plus 256, plus 2048, plus 32,768. Adding all of these together, we're going to find that our number in decimal is in fact 35,094, like so. So this has been an example or a video of how we can convert binary numbers. Well, firstly, we had a look at what is the binary number system, and then we had a look at how we can convert binary numbers to decimal numbers.